McLaren F1. The McLaren F1 is a sports car designed and manufactured by British automobile manufacturer McLaren Cars, and powered by the BMW S70/2 V12 engine. The original concept was conceived by Gordon Murray. Murray was able to convince Ron Dennis to back the project. He engaged Peter Stevens to design the exterior and interior of the car. On March 31, 1998, the XP5 prototype with a modified rev limiter set the Guinness World Record for the world's fastest production car, reaching 240.1 miles per hour, 386.4 kilometers per hour, surpassing the modified Jaguar XJ220's 217.1 miles per hour, 349 kilometers per hour, record from 1993. The car features numerous proprietary designs and technologies. It is lighter and has a more streamlined structure than many modern sports cars, despite having one seat more than most similar sports cars, with the driver's seat located in the center, and slightly forward, of two passenger seating positions, providing driver visibility superior to that of a conventional seating layout. It was conceived as an exercise in creating what its designers hoped would be considered the ultimate road car. Despite not having been designed as a track machine, a modified race car edition of the vehicle won several races, including the 1995 24 Hours of Le Mans, where it faced purpose-built prototype race cars. Production began in 1992 and ended in 1998. In all, 106 cars were manufactured, with some variations in the design. In 1994, the British car magazine Autocar stated in a road test regarding the F1, "The McLaren F1 is the finest driving machine yet built for the public road." They further stated, "The F1 will be remembered as one of the great events in the history of the car, and it may possibly be the fastest production road car the world will ever see." In 2005, Channel 4 placed the car at number 1 on their list of the 100 greatest cars, calling it the greatest automotive achievement of all time. In popular culture, the McLaren F1 has earned its spot as the greatest automobile ever created and the most excellent sports car of all time amongst a wide variety of car enthusiasts and lovers. Notable past and present McLaren F1 owners include Elon Musk, Rowan Atkinson, Jay Leno, George Harrison, Ralph Lauren, Nick Mason, and the Sultan of Brunei. In the April 2017 issue of Top Gear magazine, the McLaren F1 was listed as one of the fastest naturally aspirated cars currently available in the world, and in the same league as the more modern vehicles such as the Ferrari Enzo and Aston Martin 177, despite being produced and engineered 10 years prior to the Ferrari Enzo and 17 years prior to the Aston Martin 177. Chief Engineer Gordon Murray's design concept was a common one among designers of high-performance cars, low weight and high power. This was achieved through use of high-tech and expensive materials such as carbon fiber, titanium, gold, magnesium and Kevlar. The F1 was one of the first production cars to use a carbon fiber monocoque chassis. Gordon Murray had been thinking of a 3-seat sports car since his youth. When Murray was waiting for a flight home from the Italian Grand Prix in 1988, he drew a sketch of a 3-seater sports car and proposed it to Ron Dennis. He pitched the idea of creating the ultimate road car, a concept that would be heavily influenced by the company's Formula One experience and technology and thus reflect that skill and knowledge through the McLaren F1. Murray declared that during this time, we were able to visit Honda's Tochigi Research Center with Ayrton Senna. The visit related to the fact that at the time, Honda powered McLaren's F1 Grand Prix chassis. Although it's true I had thought it would have been better to put a larger engine, the moment I drove the Honda NSX, all the benchmark cars, Ferrari, Porsche, Lamborghini, I had been using as references in the development of my car vanished from my mind. Of course the car we would create, the McLaren F1, needed to be faster than the NSX, but the NSX's ride quality and handling would become our new design target. Being a fan of Honda engines, I later went to Honda's Tochigi Research Center on 2 occasions and requested that they consider building for the McLaren F1 a 4.5-liter V10 or V12. I tried to persuade them, but in the end could not convince them to do it, and the McLaren F1 ended up equipped with a BMW engine. A pair of Ultima Mk3 kit cars, chassis numbers 12 and 13, Albert and Edward, the last two Mk3s, were used as mules to test various components and concepts before the first cars were built. Number 12 was used to test a gearbox with a 7.4-liter Chevrolet V8, plus various other components such as the seats and the brakes. Number 13 was the test of the V12, plus exhaust and cooling system. When McLaren was done with the cars, they destroyed both of them to keep away the specialist magazines and because they did not want the car to be associated with kit cars. The car was first unveiled at a launch show, May 28, 1992, at the Sporting Club in Monaco. The production version remained the same as the original prototype, XP1, except for the wing mirror which, on the XP1, was mounted at the top of the A-pillar. This car was deemed not road legal as it had no indicators at the front. McLaren was forced to make changes on the car as a result. Some cars, including Ralph Lauren's, were sent back to McLaren and fitted with the prototype mirrors. The original wing mirrors also incorporated a pair of indicators which other car manufacturers would adopt several years later. The car's safety levels were first proved when during a testing in Namibia in April 1993. A test driver wearing just shorts and a t-shirt hit a rock and rolled the first prototype car several times. The driver managed to escape unscathed. Later in the year, the second prototype, XP2, was specially built for crash testing and passed with the front wheel arch untouched. The McLaren F1's engine compartment contains the mid-mounted BMW S70/2 engine and uses gold foil as a heat shield in the exhaust compartment. Gordon Murray insisted that the engine for this car be naturally aspirated to increase reliability and driver control. Turbochargers and superchargers increase power, but they increase complexity and can decrease reliability, as well as introducing an additional aspect of latency and loss of feedback. The ability of the driver to maintain maximum control of the engine is thus compromised. Murray initially approached Honda for a power plant rated at 410 kilowatts. 550 horsepower, 557 PS, with 600 mm, 23.6 in, a block length and a total weight of 250 kilograms, 551 pounds. It was required to be derived from the Formula One power plant in the then dominating McLaren, Honda cars. When Honda refused, Isuzu, then planning an entry into Formula One, had a 3.5-liter V12 engine being tested in a Lotus chassis. The company was very interested in having the engine fitted into the F1. However, the designers wanted an engine with a proven design and a racing pedigree. Gordon Murray then approached BMW, which took an interest, and the motorsport division BMW M headed by engine expert Paul Ross designed and built Murray a 6064 cc, 6.1 liters. 370.0 cubic inches, 60 V12 engine called the BMW S70/2. At 461 kilowatts, 618 horsepower, 627 PS, and 266 kilograms, 586 pounds, the BMW engine ended up 14% more powerful and 16 kilograms, 35 pounds, heavier than Gordon Murray's original specifications, with the same block length. It has an aluminium alloy block and heads, with bore X stroke of 86 mm, 87 mm, 3.39 and 3.43 in, dock with variable valve timing, a relatively new and unproven technology for the time, for maximum flexibility of control over the 4 valves per cylinder, and a chain drive for the camshafts. The engine uses a dry sump oil lubrication system. The carbon fiber body panels and monocoque required significant thermal insulation in the engine compartment, so Murray's solution was to line the engine bay with a highly efficient heat reflector, gold foil. Approximately 16 grams, 0.8 ounce, of gold was used in each car. The road version of the engine used a compression ratio of 11:1 to produce a maximum power output of 461 kilowatts, 618 horsepower, 627 PS, At 7,400 revolutions per minute and 650 Nm, 479 pounds-feet, of torque at 5,600 revolutions per minute. The engine's rev limiter is set at 7,500 revolutions per minute. In contrast to raw engine power, a car's power-to-weight ratio is a better method of quantifying acceleration performance than the peak output of the vehicle's power plant. The standard F1 achieves 550 horsepower/ton, 403 kilowatts/ton, or just 0.27 horsepower per pound. The cam carriers, covers, oil sump, dry sump, and housings for the camshaft control are made of magnesium castings. The intake control features 12 individual butterfly valves and the exhaust system has 4 Inconel catalysts with individual lambda-Sondian controls. The camshafts are continuously variable for increased performance, using a system very closely based on BMW's Vanos variable valve timing system for the BMW M3. It is a hydraulically actuated phasing mechanism which retards the inlet cam relative to the exhaust cam at low revs, which reduces the valve overlap and provides for increased idle stability and increased low-speed torque. At higher RPM the valve overlap is increased by computer control to 42 degrees, compare 25 degrees on the M3, for increased airflow into the cylinders and thus increased performance. To allow the fuel to atomize fully, the engine uses 2 Lucas injectors per cylinder, with the first injector located close to the inlet valve, operating at low engine RPM, while the second is located higher up the inlet tract, operating at higher RPM. The dynamic transition between the two devices is controlled by the AQ. Each cylinder has its own miniature ignition coil. The closed-loop fuel injection is sequential. The engine has no knock sensor as the predicted combustion conditions would not cause this to be a problem. The pistons are forged in aluminum. Every cylinder bore has an Icosol coating giving it a high degree of wear resistance. From 1998 to 2000, the Le Mans winning BMW V12 LMR sports car used a similar S70/2 engine. The engine was given a short development time, causing the BMW design team to use only trusted technology from prior design and implementation experience. The engine does not use titanium valves or connecting rods. Variable intake geometry was considered but rejected on grounds of unnecessary complication. As for fuel consumption, the engine achieves on average 15.2 miles per gallon, 15 liters/100 kilometers, at worst 9.3 miles per gallon, 25 liters/100 kilometers, and at best 23.4 miles per gallon, 10 liters/100 kilometers. It was later revealed that BMW had used an E34 M5 Touring as a test mule in order to test the engine. The existence of such a test mule was revealed when David Clark, the director of McLaren road and race cars from 1994 to 1998, disclosed this fact to motoring journalist Chris Harris in a podcast. Clark also revealed that the prototype was kept out of public eye and that BMW is still in possession of the prototype where it has been kept in their top secret prototype storage facility.